All right, so find the degree of each polynomial, the zeros and their multiplicity. So degree is easy to find in standard form. So for this polynomial, the degree would be 3. But the zeros are harder to find. You have to put the original polynomial into factored form. So how could we factor this? We could pull out a greatest common factor of x squared, 2x squared, I guess, and we'd have x minus 3 left. So now I can see that 0 is one of my zeros, because if I plug in 0 here, I'll get 0 times negative 3, which is 0. Its multiplicity is 2. If I wrote this out in fully factored form, it would be 2 times x times x times x minus 3, so that factor of x shows up twice, which is an even amount. And then x minus 3 produces a 0 that is positive 3. The multiplicity would be 1, which is odd. And remember that even and odd multiplicity affect the graph. The graph's going to bounce off the x-axis at 0, but it's going to cut through the x-axis at 3. On part B, this is already in factored form, so you need to go backwards to standard form. You don't have to multiply this all out though. You could just think of this as an x squared term. This is x cubed, so this is a total of x to the 5th. So it's a 5th degree. I can read my zeros directly from these factors. So one of my zeros is negative 1/2. If I set this equal to 0, I would subtract 1 and divide by 2. So negative 1/2 is a 0. Its multiplicity is 2, which is even. Again, if I wrote this all the way out, I would have 2x plus 1, 2x plus 1, x minus 3, x minus 3, x minus 3. So multiplicity is asking you, how many times do you see that factor? I see this factor twice. I see this factor 3 times. So 3 is one of the zeros. It has a multiplicity of 3, which is odd. So the graph would bounce off the axis, cut through the axis. So let's see, now we're finding the vertex of a parabola. This is in vertex form, so I can just read that it goes right 5 and up 3. So my vertex would be at 5, 3. This is in standard form, so I need the formula negative b over 2a. The opposite of b would be negative 4. 2 times 1 is 2. My x value is negative 2. I'm going to plug that back in for x. I would get 4 minus 8 minus 1 comes out to negative 5. So negative 2 comma negative 5. Let's see. This function, what is its degree? It's in standard form. The highest power is 4, so the degree is 4. The turning points are always 1 less than the degree, so the maximum turning points would be 3. The end behavior, the right side goes up because I have a positive leading coefficient. The left side goes the same way because I have an even degree, so up, up. The coordinate of the y-intercept, I plug in 0 for x, and I would get 5 for y. All these terms would go to 0. 0, 5 is my y-intercept. Identify the key features and graph the function. This is an absolute value graph. It has gone right 3 and up 5, so 3, 5 is the vertex. It has a slope of 1, but it's been flipped upside down. So down 1 over 1 in each direction from the vertex. It's a V-shaped graph. Number 5 is a parabola in intercept form. So your first step is to graph the intercepts. Negative 1 and positive 3. Your x value of your vertex must be 1 because that's halfway in between the two x-intercepts. So now I'm going to plug 1 into the original function. So 2 times 2 times negative 2 is negative 8. 1 comma negative 8. And the parent function is being stretched by a factor of 2. So normally I would go over 1 from the vertex and up 1. This time I'm going to go over 1 from the vertex and up 2. And then this is over 2 up 8. So this is a parabola that's been stretched by a factor of 2. So this time I'm going to graph the function. I can use a calculator on this part so I can identify zeros. So this is a polynomial function, not factorable. So I'm going to use the calculator for this part. So look at the y equals menu, x cubed minus 4x squared plus x plus 6. Zoom 6 to see what's going on. Looks like I have an x-intercept at -1, 2, and 3. I'm going to verify in my table. So let's see, -1, 2, and 3 looks correct. So -1, so -1, 2, and 3. So I'm going to graph -1, 2, and 3. Go back to my graph. So it went up here. So I need to find these two turning points. I already know that it has a y-intercept at 6. So I'll graph 6. I know that it goes straight down. So I need two turning points. So to figure out my turning points, I go to second calculate maximum. Go to the left bound, enter. Go to the right bound, enter twice. So that maximum is at 0.13, comma 6.06. So that's just about here. It like barely goes higher than the y-intercept. And then it goes down through here. And then I need this turning point, calculate the minimum. There's the left. There's the right. So it's at 2.54, 2.54, comma, -0.88. So 2.54, -0.88 is about there, and then it goes back up. Let's see, domain and range would both be all real numbers because the graph's going forever in this way and forever this way. This is a square root function that I can do without a calculator, so it's gone right 4. And the square root of 1 is 1, so I can go over 1 up 1, and the square root of 4 is 2, so I can go over 4 and up 2. All right, so the 0 is at 4, 0. It doesn't have any turning points. The domain would be x is greater than or equal to 4, and range y is greater than or equal to 0. Factor and solve these couple. This is a 4 different terms, so I must have to use grouping. So I group together the first 2 and the last 2. Taken out an x squared, I'd have x plus 1. Take out a -9, I'd have x plus 1. X plus 1, x squared minus 9. I'm not quite done. That's a difference of squares. So my final answer, x plus 1, x plus 3x minus 3. Oh, it says equals 0, so I need to go one step further. X is either -1, -3, or +3 would be my final solved answer. On B, this looks like a greatest common factor of 4x squared, and I'd have x minus 9 left. So my two solutions are 0 or +9, coming from those two factors. This is a good quadratic application problem that you had to do once during the virtual week, so good review. A rectangular pen has one side being a straight water drain, and then they need 3 sides to make their rectangle. 1,000 meters of fencing are available. So let's call this x, call this y. So 2x plus y has to add up to 1,000 meters of fencing. So that's using my perimeter. We want it to enclose the largest maximum area. So like area is x times y. So I can't solve this area equation unless I have it in terms of either x or y. So up here in the perimeter equation, what we can do is actually solve that y equals 1,000 minus 2x. So we can take that 1,000 minus 2x and plug it in for y in this bottom equation. So area equals x times 1,000 minus 2x. So I should have written it as 1000x minus 2x squared, or better yet, negative 2x squared plus 1000x. This is a concave down parabola that has a maximum. So if I can find its vertex, I'll find the maximum area and the dimension of x. So I need to do negative b divided by 2a. So I get that negative 1000 divided by negative 4 is 250. So that's x. So if x is 250, looks like I would have 500 remaining for y. So my dimensions are 250 by 500. And what is 250 times 500 would give an area of 125,000 meters squared for the maximum area.